Ham radio. You know a little bit about it, but you want to learn more. You want to expand upon the basics of your knowledge, you want to get on the air, and you want to build that first ham shack. Let's talk about it. Hey guys, I'm Eric, VA3FYB, the ham radio hoser. Let's jump right into it. Welcome everybody. Today's presentation is an introduction to ham radio part 2, expanding upon the basics and getting started in ham radio. So the scope and intent of today's video is, firstly, we're going to build and expand off of part 1. I have done a previous video, part 1 of course, kind of going over the basics and introductory foundation to ham radio. We're going to build off of what we learned and covered in that video and presentation, both practical and theoretical knowledge. I want to equip and enable your independence. So equip you with enough practical information to enable you to get started in the hobby independently, or at least inform you enough so you can better teach yourself and continue to learn at your own pace in what you specifically are interested in. And then, ideally, by the end of the presentation, I want you to have a rough idea of what you are going to be interested in and initially want to cover in the hobby, and how you can build your first ham shack around those interests. But I also want you to keep in mind that your interests will expand and evolve over time, and thus so will your ham shack and your equipment in it. So table of contents, what are we going to go over in today's presentation? Firstly, how interested are you? Are you a little interested or are you a lot interested in amateur radio? Start listening now. We'll see what that means later. We're going to do a recap of RF and electromagnetic spectrum basics. Just a quick recap. We're going to go over the bands in depth. We're going to cover license classes and call signs and the privileges associated with those classes. The radios and not bands, but brands. The brands within the amateur radio community. We're going to cover antennas. More in depth about antennas. We're going to cover this thing called polarization. 9, the big one, your first ham shack. How do you go about building your first ham shack and radio equipment in amateur radio? And then 10, we're going to do a little recap, just talk about the things and kind of boil it down what we covered in the presentation, so you got a nice, neat little list to carry with you and think about. So firstly, how interested are you? A little or a lot? So what you do after this video is going to depend on your interest level. And we're going to kind of split it up into 2 categories here. A little, I'm just going to dip my toe into the water into this ham radio thing, versus a lot. This is totally up my alley, totally me. I just want to dive headfirst into the pool, into this ham radio thing. Give it all. Well, the easy thing is if you're a lot interested, highly interested, it's as simple as get licensed. Book your course and take that test. Your first test is essentially a license to learn. You'll often hear that within the hobby. So if you know that this is definitely something you're going to totally dig, just go book a course and take the test, get licensed. It's that simple. After watching this video, if you haven't already, if you don't have your license, if you haven't booked a course, just go and do it if you know that that's your thing. Now, if you're more on the little kind of interested thing, well, you can further inform yourself, do some more research, and see if this hobby is something that interests you. Though if you're watching this video, I'm assuming you are already in the a lot interested category, but we'll cover these guys as well. So what can you do about it after watching this presentation? There's a myriad of videos and very much more smarter people than me on YouTube talking about it, so YouTube is your best friend when it comes to learning about ham radio. There are podcasts, of course. Yes, there are still paperback books. other hams in your area. Maybe you don't have your license yet, but you do know that there maybe are some amateur radio operators in your local area, town or city. You can always contact them. A local ham club, if you're lucky enough to have a local ham club in your area. And then, of course, this presentation. I hope, I hope by the end of this presentation, if you are in the a little category, that you do transfer over to the a lot category. So, start listening now. You don't have to wait. You don't need a license to listen to the airwaves, so you might as well start listening now. It might pique your interest and get you more involved in the hobby, or completely cement the fact that you want to dive headfirst into this thing. So, listening now, we can do that a couple different ways. SDRs and shortwave listening. So what are SDRs? Well, SDRs are software-defined radios, and they come in many different form factors. The packages we're going to be talking about today, we're going to focus on SDR dongles mainly. SDR dongles, what are they? Well, they're devices that accept an antenna on one end of the device, and then they plug into your computer's USB port with the other end, and through downloadable software, you can see and hear wide swaths of the radio spectrum, given that it's plugged into a decent antenna. SDR dongles are primarily, for the most part, receive only. They don't usually transmit. There are some exceptions. But they allow you to view a huge portion of the radio spectrum and listen in on almost anything given a good enough antenna. Believe it or not, a simple random length of copper wire will actually make a decent antenna. And time with one of these will give you a good sense of whether you truly find the radio interesting or not. Cheap. There is a decent amount of cheap SDR dongles out there, and even though they're cheap, they are effective. So you really don't have anything to lose by trying one out, but you can, if you want, if you've got the cash, certainly get more expensive radios that have tons of features and superior quality to them for sure. And actually, if you don't want to spend any money before you even get an SDR, there are web SDRs. And there's many SDR websites that exist that have SDR receivers placed all around the world. And there's usually individuals, all over the world that go out, put up a good antenna, connect it to an SDR, and then connect that SDR to the internet for your viewing and hearing pleasure. You can go to the website, pick an SDR of your choosing, and listen into all the radio waves that that specific area has to offer. And you do this all without buying your own SDR receiver, so it's free. And even though you might go this path of web SDRs, I do highly recommend you get even one of the cheaper SDRs. They're pretty fun. So a couple of websites here, websdr.org and KiwiSDR/public. These are a couple of decent websites where you can access some web SDRs before you go and buy your first one. And then up in the corner here, we got a couple of different pictures of SDRs. The one in the middle there, that black SDR play, is a higher end, expensive, yet very nice SDR receiver. The one on the left is a classic one that a lot of people start with, the RTL SDR dongle. And on the right, you can see you can buy it as a single stick, or you can buy it as a kit. It's got some antennas and coax and a stand and stuff like that. Now, alternatively, you could actually get a dedicated traditional shortwave receiver that sits on your countertop or something like that. It may not have the nice waterfall or spectrum display that you'll get in the software on a computer that an SDR would. But it still has many of the features, if not all the features that an SDR would, just minus the graphical display. Or if you're not talking about HF and shortwave, but you're thinking about VHF, UHF, and scanning, you can always get a traditional scanner. To To be honest, nothing truly replaces a dedicated scanner. Nothing will ever replace that or be better than a proper dedicated unit, but good ones are gonna be expensive. There's no way around it. Here's a kind of a slide that I put together. As you can see in the bottom left, that's a nice SDR Play receiver. And at this time, there is a different program, an updated program from SDR Play. But when I was getting into SDR Play units, this is what the software kind of looks like. So you can see on the main big screen there, the bottom panel, you've got your spectrum display. That's all the spikes across the radio spectrum. Below it is a waterfall, so it's kind of recording everything over time. And then up on the top couple of panels, you've got things like setting and sideband and frequency and modes and stuff like that. It's kind of confusing. There's a lot going on, but these are very, very full-featured units, and they do a lot, and they are very high quality. So let's do a quick recap on radio frequencies and the electromagnetic spectrum. So radios generate waves at given frequencies, usually at a single frequency at a time. We can measure this in either frequency or wavelength. So the base units are hertz and meters, but given the metric system and its prefixes, we can expand upon that. Kilohertz, megahertz, gigahertz, meters, kilometers, etc. These frequencies lie somewhere along the electromagnetic spectrum, and what is coming out of our radio, these radio waves, is essentially the same stuff, as it were, as cosmic rays, gamma rays, X-rays, UV, visible light, infrared, microwaves, etc. The only thing different is, besides power level, is essentially the frequency or wavelength. It's all electromagnetic radiation. Again, if you watch the previous video, this is a really decent picture that I pulled out. We can see all these things, these different waves or forms of light lie across the electromagnetic spectrum. It's all the same stuff, just different frequency / wavelength. Again, there's a sine wave. And for those who are interested, this little formula here, V equals F lambda, or velocity equals frequency times wavelength, or C, which is the unit for the speed of light, equals frequency times wavelength. C is the absolute speed of light in a vacuum. It's pretty close to what light would be in Earth's atmosphere, but not exactly the same. This formula is inversely proportional. Frequency and wavelength are inversely proportional, which means if the absolute speed of light, or whatever our speed of light is in the given medium, stays the same, if frequency goes down, wavelength has to go up. If wavelength goes down, frequency has to go up. That's what inversely proportional means. And there's a little graphic there. As you can see, big frequency, short wavelengths, small frequency, large wavelengths. And radios alter or modulate the signal coming out of our radios at a given frequency, and we do this to impart information on the signal, such as the human voice, music, telemetry, digital data, etc. And a nice little GIF there of our carrier signal that our radio's generating, and ways we can impart information onto that carrier signal, such as amplitude modulation or frequency modulation. So the bands, what and where are they? Bands, as we call them, are essentially just slices of frequencies that we hams are allowed to transmit on. And what do I mean by a slice? Well, that just means that there's a start and a stop frequency, and that's what defines the band. So example, the 40 meter band starts at 7 megahertz and ends at 7.3 megahertz. So there's a start and a stop. That little box, that is the band. There are multiple bands spread out across the entire radio spectrum. Each is kind of like its own little sandbox, as it were. Ham bands are broadly defined by the International Telecommunications Union, or the ITU, and then they're further refined by each country's government and lobbying body of that region. We, meaning us in North America, are in ITU Region 2. Here's a little map of the ITU regions. You can see there's three. We got North and South America. My apologies. You've got Europe and Africa, and then we've got Asia and Oceania for the different ITU regions. And these are the ITU Region 2 sandboxes. Again, they're kind of broadly laid out by the International Telecommunications Union, and then further restrictions and privileges and modes and planning is then further made by the government, and usually it's helped out with the main lobbying body of that country. So for example, in Canada, it's the Radio Amateurs of Canada, RAC, or if you're in America, the American Radio Relay League, the ARRL. So as you can see, here's, I believe, don't quote me on it, an extensive list of all the bands laid out for ITU2, all the way from 2.2 kilometers, 2200 meter band, all the way up into 1 millimeter, the 1 millimeter band. So you can see the band name, how we define it by wavelength, and then there's going to be a start and a stop frequency. That start and stop, that's the band. So, each country's government has the job of divvying up the radio spectrum amongst its countless users. Hams are not the only users by any stretch of the imagination. One of those many users are us. Hams have many bands spread out across the entire spectrum. And you can kind of think of this analogous to if the entire radio spectrum is a big soccer field, bands are like little sandboxes spread out across that soccer field. So you've got a couple of 2x4s in a square, you got the sand inside, you got to play inside the sandbox, but you have multiple and they're spread out all across that soccer field. It's kind of how I like to think about bands across the radio spectrum. Here is a graphic that I pulled off the Government of Canada website. I'm Canadian from Canada. As you can see, this is all the different types of communications and users and bands spread out across the entire spectrum. The government has a job of divvying that up and regulating that. That's not an easy task, and we shouldn't take that for granted. And then of the ham bands in Canada, this is the Radio Amateurs of Canada band plan. This is kind of how they lay out the different bands that we have and what we do and where we do it on that band. This is just for HF though, nothing. These are all the bands below 30 megs. And then for another example, I pulled this PDF off of the United States government website. As you can see, it's pretty similar to the Canadian one. Government's got to split that up and divvy that up amongst thousands and thousands of different users. It's not an easy task. And then from the ARRL, we've got the US Amateur Radio Band Plan. Understanding the bands. Commonly used bands and their characteristics. There's kind of some confusing language and conflicting interchangeable language when it comes to bands, so we'll try to straighten that out for you. So often when we're referring to or talking about a band, you'll hear it talked about in two different ways. You'll either hear its wavelength mentioned or its frequency mentioned. So for example, the 40 meter band could also be called the 7 megahertz band. It's the same band, 7 megahertz to 7.3 megahertz, but it's sometimes, or more often actually, referred to as the 40 meter band. But you'll hear those two types of ways of talking about the band used interchangeably. So, interchangeable confusions. Hams have a really, really bad habit of using multiple names for multiple things, not just bands, interchangeably, and it's understandably confusing for newcomers. I know it certainly was for me. So in the beginning, remembering all the bands and the different ways that they can be talked about or referred to might seem pretty confusing and annoying, for sure, but don't worry about it. Eventually, just through hearing it so many times, you'll become accustomed to all the different names and you will start remembering it all. So, this is kind of how you might, how we refer to bands usually, the patterns that you'll notice. We often refer to whatever has the fewest syllables, and that's the one we use the most. We're kind of a lazy bunch. So, for example, 70 centimeters, there's a 70 centimeter band. 70 centimeters is 7 syllables, while 440 megahertz, or just 440, is 6 and 3 syllables respectively. So 70 centimeters versus 440 megahertz, or even 440, you're gonna see 440 used more often just because it's got less syllables and it's easier to say. So if you're ever confused as to which one they're talking about, or what people usually commonly call the band, whatever the easiest to say, whatever has less syllables is usually what's going to be used. And bands can kind of be split up into line of sight versus beyond line of sight, kind of how we're utilizing what we're doing with that band. Roughly speaking, line of sight is above 30 megahertz and beyond line of sight is below 30 megahertz. Now, this is a general rule of thumb. Please take it with a grain of salt. I'm doing this 30 and above 30 and below 30 megahertz separation purely because VHF is defined by the ITU as 30 megahertz to 300 megahertz. If you can remember how the ITU defines bands from our previous video, everything has a 3 in it and it's on an order of magnitude or multiple of 10. So VHF is 30 megahertz to 300 megahertz, and HF is 3 megahertz to 30 megahertz. So that's why I've chosen 30 as the cutoff point. There are definitely exceptions, for example, like the 6 meter band, or even VHF tropoducting that we get on 2 meters under ideal conditions. That allows us to talk way further, sometimes even hundreds of kilometers or miles away. They do break this rule, obviously, and there's other examples, but I kind of just did this for ease of conceptualization for beginners. So, some common examples of bands. There's so many bands, it's hard to remember them all, but if you can remember the most commonly used ones, it makes things a bit easier to understand and remember. So, beyond line of sight and line of sight above and below 30 megs. Couple of ones that are below 30 megs. We've got our nighttime bands, so that's 160 meters, 80 meters, and 40 meters. Those are the big ones. And then for our daytime bands, we've got 40 meters, which is more local / NVIS, 20 meters, 15 meters, and 10 meters. Now, what do I mean by a nighttime, daytime band? Well, it's pretty self-explanatory. Ideally, 160, 80, and 40 meters, they work better and they go farther and they stay open longer during the night. And then 40 meter NVIS, and then 20 meters, 15 meters, and 10 meters, so the upper part, the upper bands, they're more active to talk farther and stay open longer during the daytime. Now, with that being said, there's a couple of caveats. High and low solar cycle and summer and winter. These kind of change the characteristics of these bands, and you might see things become more nighttime or more of a daytime band depending on those factors. What constitutes a nighttime band versus a daytime band changes with the solar cycle and seasons due to sunspot and solar radiation activity, which affects our ionosphere. Just for an example, a high solar cycle during the summer is going to have the highest solar activity of any of those combinations. Meanwhile, low solar cycle and during the winter is going to have the lowest solar activity of any of those combinations. It's an interesting topic, but it's beyond the scope of this video, and I don't profess to be an expert in solar and sun weather, so that deserves its own video, and probably from somebody who's a bit more knowledgeable than myself. Now, for our line of sight bands, two most common, hands down, are 2 meters and 70 centimeters. There's many others, of course, because we get way up into the SHF and EHF frequencies, but 2 meters, 70 centimeters are the most common ones you're going to hear by far. And like I said, 70 centimeters often gets referred to as 440 a lot of the time. So those are a couple of the main bands. If you can remember some of those, that's like 80% of the bands you might ever use in the hobby. 160, 80, 40, 20, 15, 10, and then 2 meters and 70 centimeters. That's going to be like 80%. That's your bread and butter in the amateur radio world. Now let's go over license classes and their privileges and kind of what is expected depth of knowledge wise within those classes. So I'm going to cover both Canadian and American licenses. Like I said, I'm Canadian from Canada, but I appreciate they're just sheer numbers wise, there's going to be way more Americans than Canadians. Just numbers wise there is, but also watching this video and being on YouTube. So I think it's fair that I should cover both. So in Canada, we have 3 license classes, but only 2 tests. It's kind of a weird system, I know, but for one of the tests, your first test, there's 2 possible outcomes depending on your grade when you pass. So your first test / license is basic. You got to get a 70% to pass, and the test is 100 randomized questions pulled out of a pool of 971. I checked that last month. It does change. What do you get privilege-wise with your basic license in Canada? You get all bands above 30 megahertz. You get 250 watts of DC into the final amplification stage, which comes out to be about 560 watts peak envelope power. PEP is how we measure single sideband, or SSB, because with the cadence and loudness and volume of your voice, the output power changes on your radios. So with SSB specifically, so that's how we measure SSB. And 250 watts is into the final amplification stage. So you have some room for amplification, even with your basic license. You can build commercially available and professionally designed kits, but you can't homebrew from scratch. You can't go to your nearest electronics store, capacitors, inductors, circuit boards, design your own circuit boards and get them printed and shipped to you. You can't do that and build your own radio from scratch, unfortunately, with your basic license. Yeah, but you can do professional kits. You get kits that come with all the parts and pieces, a set of instructions. You can build those just fine. You are allowed to reprogram equipment till your heart's content. So just hooking up your radio to a computer or via an SD card and reprogramming it however you see fit is a-okay. You can use repeaters. Repeaters are essentially another radio, usually with a height advantage and power output advantage that allows us to increase our radius of coverage that we can talk with our radios. You can use crossband repeaters, won't get into it too much, but there's radios out there that do this thing called crossbanding, and you can do that with your basic license, no problem. Unfortunately, though, you're not allowed to remote in or controlled fixed stations are permitted, not allowed that, regardless of the medium for control. So it doesn't matter if it's RF linked, if it's through the internet, what have you. You can't use remote controlled stations. Even though it might sound like it, repeaters don't technically count in this remote control rule. Now, basic with honors, it's the same test as your basic test, but if you get above 80% or above on that basic exam, you get what's called basic with honors. So it's the same test, but it's a different outcome based on your grade. Kind of strange, I know. There's only a 10% margin of error to get your basic, but if you get above that 80%, you get this basic with honors, which gets you all the aforementioned privileges, of course, plus access to all of those bands below 30 megahertz. So all of your beyond line of sight HF bands, you get them with your basic with honors. And our third license class, which is its own test, is advanced. Again, you need a 70% to pass that one, but it's only 50 randomized questions out of a pool of 549. Now, the questions are harder for sure, but you've only got 50 of them, so I guess it's up to you whether you think that's of benefit or not. And what do you get privilege-wise with your advanced license? Well, you get up to 1,000 watts DC into the final amplification stage, which comes out to about 2,250 watts peak envelope power. So you can run those big, full legal limit amplifiers on your HF rig, no problem. You can build and operate equipment from scratch, so you can homebrew. You don't need to rely on commercially available kits. You can modify radio apparatus by computer program or physical modifications to the circuitry. So essentially you can take, you can code-wise edit the radio, or you can physically open the radio and mechanically remove and put back in and solder parts and modify your radio that way, which you can't with the previous licenses. You're able to establish your own repeater and club stations. So if you want to start a club station, or if you want to build and operate and be a repeater manager of your own repeater, you got to get your advanced license to do so. And you can now finally use remote control stations and radio links, no problem. And last but not least, we have this thing called the Morse code qualification in Canada. It's not really its own license class, it's more akin to an add-on, because it can be added on to either your basic with honors, or advanced license class. And even though we have this Morse code qualification, it's not actually required to use and utilize Morse code on its own. No matter what license class you have, you can use and utilize Morse code perfectly fine without this qualification. It's just an add-on. To get it, you gotta send and receive Morse code at a speed of not less than 5 words per minute for 3 consecutive minutes, which is, on a technical level, quite easy. 5 words per minute is extremely slow, but at the same time, if you're doing bare minimum, 5 words per minute is painfully slow. So it's not a hard qualification to get, but you definitely don't want to be learning and practicing Morse code that slow, for sure. And what this gets you, actually, is access to all the amateur bands. Now, in most cases, Morse code qualification is going to be more like bragging rights / completing your license class. Doesn't really do much for you besides show up on your nice piece of paper certificate. But if you're in this weird position where you're above 70% on your basic exam, but you're below 80%, so you didn't quite get your basic with honors, but you were somehow able to manage passing your Morse code add-on, you do get access to all the amateur bands. It's a really rare circumstance and a rare case, but if you're one of those people, the Morse code qualification does give you access to all the amateur bands. Now, that's it for all our license classes in Canada. Remember, 3 classes, but only 2 tests. It's kind of weird, I know. But in the United States, if you weren't already aware, there's 3 license classes, and they do actually have their own individual tests associated with them. 3 tests and 3 outcomes versus our kind of strange 2 tests, 3 outcomes. The initial test that you'll get in America is called Technician. It's 35 questions, and you got to get 26 of 35 correct in order to pass. You do the math on what that percentage is. And what do you get? Well, you get full privileges in all bands above 50 megahertz, so above 6 meters. You get 1500 watts peak envelope power, limited privileges below 30 megahertz. So for example, on 80 meters, 40 meters, and 15 meters, you can operate Morse code, or as we colloquially call it, CW. And you can do CW and SSB on 10 meters, though you're limited to 200 watts maximum power. Your next step up license class, the middle tier, is called General. It's 35 questions, and again, you need the 26 out of 35 to pass. So some of the privileges in general, you get basically almost all privileges on all of the bands. Almost. Something I pulled up from Wikipedia was basically general class license holders have access to over 83% of the available amateur HF bandwidth. So you've got almost all of it, but not quite. You can use digital modes with your general license. And upon accreditation by a volunteer examiner coordinator, an individual can help administer certain examinations. To become an accredited examiner and help out in Canada, it's a more complicated and different process. It's more easy with your general class license in America. Now the next license class level is Amateur Extra, or usually just referred to as Extra. It's 50 questions, and you got to get 37 out of 50 in order to pass. Again, you do the math. I don't know what that is percentage-wise. The privileges you get are full spectrum privileges. Once you get your Amateur Extra, or just your Extra, you got privileges to all the amateur bandwidth. I know the American side might seem a little short, but I did have a hard time finding information from both the ARRL and the FCC compared to the information that I could find on RAC and ISED. I don't know if that's because I'm in Canada and Google is just giving me less information algorithm-wise, but I did find it harder to find in-depth information as compared to the Canadian stuff. So do your own research and find out more information if you need. All right, call signs. We're going to go over call signs really quick. Call signs are our way of identifying ourselves. Essentially, what it boils down to, they're a form of identification that lets others know who we are and what we are licensed to operate, where we're operating. You got to have a valid call sign to go with your valid license in order to operate. And in Canada, you're required to identify with that call sign every 30 minutes, and in the US, you must identify every 10 minutes. Just a formality difference between the two countries. Now, not only hams, but also AM and FM radio stations, TV stations, rebroadcast stations, etc. They also have call signs. It's not just for ham radio guys. Every once in a while, if you're paying attention to an AM or FM radio station in your car, you might hear them throw out their call sign. And if you hear kind of a strange mixture of letters and numbers come over the radio, that's what it is. It's that radio station's call sign. Now, requesting a specific call sign in Canada, when you submit your paperwork after passing your exam, you can request a specific call sign. And if it's available, it'll be assigned to you. But if you choose not to request a specific one, the next available one in the computer is just going to generate it, spit it out, and that's what's assigned to you. In the United States, however, you get assigned a call sign when you get licensed no matter what. You don't get to choose. And then afterwards, you have to apply for what's called a vanity call sign if you want something custom. So for Canadian call signs, they primarily have a 3x3 or a 3x2 structure. There's exceptions, but they're extremely rare. But what does that mean exactly, 3x3 or 3x2? Well, essentially it means the first three characters are a prefix, and the last three, or last two characters, are a suffix. In Canada, the prefixes, so the first three characters, are based on which province or territory you reside in. So when you get licensed and you give your address, they need to know your address, and they do need to know your address if it changes. You get a specific prefix. It's the suffix that usually changes. Now, Canadian amateurs may have as many 3-letter suffix call signs as they want, but you only get one 2-letter suffix call sign, which can only be obtained after being an amateur for more than 5 years. So, as many 3x3s as you can handle, but you only get one 3x2 up here in Canada. Now, for American call signs are a bit more complex. I mean, they have a lot more states versus provinces and a lot more people, so it's understandable. And they have 3 parts. You've got a prefix, a region, and a suffix, and that's kind of how they're laid out. And because of that, it's a bit more complicated, but you also have more possible call sign structures. Couple of possibilities are 2x3s and 1x1s. These are available to all licensed classes in America. And you will notice there's going to be a number by a number. The first number is how many characters the prefix is. The last number is how many characters the suffix is. What's not included is the region, which is always one number, and that's given to you based on where you are, where your address is. So a 2x3 is actually going to be 1, 2, 3, 4, 5. It's actually going to be 6 characters long, 2-letter prefix, 1 number for your region, and then 3 characters after that. A 2x2, for example, is another one, but only advanced and extra class license holders get this option. And 2x1s and 1x2s are purely for extras only. Now to visualize this, I have some graphs. As you can see here in Canada, across the entire country, these are the available prefixes and how they're doled out by region. You can kind of see the main lower corridor of Canada there, all the way from BC to Quebec. You have 2 possible prefixes, a VE and a number, and then a VA3 and a number. That just gives more possibilities. And the number is basically what the province is. And then you have some single options in places like the territories and out east. I won't go over all of it, but you can see there's a nice graph there pulled from Wikipedia on the left-hand side. It kind of goes over the prefixes and the associated province or territory. For America, it's kind of complicated. There's lots of different permutations and options with call signs, but the main thing to understand is that the region, that number in the middle, is based on this chart here. You've got 6 land, 7 land, 0 land, 5 land, 4, 9, 8, 3, 2, 1, KL, KH6, KH7. All your continental United States, the other 2 other states, and then your territories of the United States. They all have a number that's associated with them based on region. And then you've got your permutations of prefix and suffix. But enough about call signs. Let's talk about radios. What do they look like, and what form factors do they come in? There's no steadfast rule, but the way I see it is you've got 5 main form factors of types of radios that you will see in ham radio. Those 5 form factors are the base station, which you can kind of think of as a desktop, a mobile, which is in the car sometimes, but also sometimes at home. Portable, the portable form factor is usually utilized in the field, portable operations. Handhelds, those are always pretty standard on your person. And then we have this thing called a shack in the box. Shack in the boxes are kind of like jack of all trades, master of none. They don't do any one thing perfectly or the best, but they do everything okay. Not mediocre, pretty well, but just okay. They're not specializing in one specific thing. Of course, there's always exceptions to the rule. There's going to be some quirky and unique radios that don't exactly fit into a hardline category. That's okay. Like I said, this is a general rule of thumb in the way I see the radios available to the ham radio market. Now, these are physical form factors that you will see radios come in. How we utilize them and what bands and frequencies they operate on is primarily split into 2 main methods or forms of communication. Of these methods of communication, we've got beyond line of sight and line of sight. Again, we've kind of talked about that previously, horizon and beyond the horizon. And again, that kind of splits into 30 above and below 30 megahertz, VHF, UHF, and SHF, and some EHF stuff as well for line of sight, and then HF, MF, and LF for beyond line of sight or below 30 megahertz. Our handheld and our mobile, they kind of fall into the line of sight things. A lot of them are usually dual band, 2 meter and 70 centimeter rigs. Our base stations are big HF rigs that are about 100 watts, fall into the beyond line of sight category. And then things like our shack in the box and our portable rigs kind of do both. Something like that 991A there on the bottom, that shack in a box, it'll do 100 watts on HF, and it usually does, I believe, 75 watts on 2 meters and 50 watts on 70 centimeters, or maybe it's 50 watts on 2 meters and 40 watts on 70 centimeters. It's something like that. So you get HF and VHF, UHF in that rig. But it is meant to go on the desk. Something like that 818ND there on the top is a portable rig. It does only 5 watts, but it does have all of the bands, HF, VHF, and UHF, and it comes in a nice small portable form factor that you can take into the field with you. Again, use cases are handhelds, carry around on your person, your mobiles usually in your car, but because of what's available on the market right now, most of us do have one in our house as well. Shack in the box is usually at the house on a desk, as well as the desktop rig, and then the portable one taken out into the fields, hiking, camping, what have you. And we covered kind of what the frequencies are, and the power ratings and associated distances that you can expect. A note on brands. Like anybody getting new into any sort of hobby or domain, there's going to be brands out there that you aren't familiar with because you're brand new to the hobby. We'll talk about the brands that you would see and expect and what you can expect from those brands within the amateur radio hobby. So, Japanese radios, the big three. There's 3 main companies that sell and provide the high-end, really reliable radios in amateur radio, and they're all out of Japan. They sell all over the world, of course, but headquarters and where the company's located and engineered and designed is in Japan. The big 3 companies, ICOM, Yaesu, and Kenwood. Those are 3 names that you'll hear all over. These companies come out of Japan, like I said, and are high-quality, very well-made radios. Somebody like Kenwood, actually, their main market is commercial and emergency service radios, so you might see, if you know anybody or you personally are in the business or emergency services fields, you'll notice a lot of Kenwood radios in those fields. But even though that they are in the commercial and emergency space, they do actually make ham radios, and they have been making them for quite many decades. High quality. So these radio companies exude high quality. That's kind of what they're known for. You can't really go wrong with them. They are reliable. They, for the majority of the time, won't let you down. They're tried and true. But you get what you pay for, as the saying goes. They're more money, but for that more money, you do get better quality, features, and reliability. So you gotta ask yourself, is it worth the money for you specifically? In short, you can't really go wrong with any of the big 3, but they do have entry-level options available that won't entirely break the bank. So if you do want one of those 3 main companies as your first radio, they do sell not cheaper, but less expensive options, entry-level options for sure. Can't go wrong with any of them. If you pick an ICOM, if you pick a Yaesu, if you pick a Kenwood, you're going to be good to go. You don't have to worry. Now, the elephant in the room when it comes to ham radios. In recent years, many cheap and massively produced radios coming from China have popped up all over the world, all over Amazon, all over the different places that you buy radios, and they're mainly coming out of China. And the big new player in town, of course, is the infamous Baofeng. The influx in cheap Chinese radios initially started with the infamous Baofeng, but many derivative radios and radio companies have popped up all over the place as well. When it comes down to it, they're almost entirely selling the same thing. They're not terribly different. Yes, these Chinese radios are definitely of lesser quality and less reliable for sure than the Japanese variety, but they're also cheaper and they just work, as it were. If you don't need any of the fancy bells and whistles, why pay for them? If you're fine with less features, yeah, they're cheaper, which is nice, and they just work. So maybe a more expensive Japanese radio doesn't interest you at this point in time. So ham radio is supposed to be fun. Don't worry about breaking the bank when you get into the hobby. If your budget doesn't allow for a radio from one of the big three, but you can afford a Chinese radio, that's okay. And don't let anybody tell you different. There will be people who will tell you different for sure. Don't listen to them. Just don't. The barrier to entry is much lower for these radios, and that's what's so great about them. They allow virtually anyone to get into the hobby, especially those on a tight budget. So if you start to enjoy the hobby, though, later on, and you want to expand your horizons, you can always upgrade to a better radio later. So there's nothing wrong with starting out with one of these Baofangs or Baofeng derivative Chinese radios to begin with. Now, with that being said, there are some higher-end Chinese radios, some companies that have been around longer than the Baofeng for sure. I wouldn't particularly say that they're ICOM, Yaesu, or Kenwood level, but they're definitely a lot better and higher end than the Baofeng for sure. Some of these companies that you might come across, Waxen, Ocean, Wushan, however you want to say it, TYT, and Anytone. Those three other guys all come out of China as well, but they're definitely superior in quality. They're kind of an in-between between the Baofeng and the higher class Japanese radios, but they're still great. And not only are they much better quality and richer in feature, but these companies specifically do actually make and sell some pretty unique and quirky radios that fit very specific niches. And if you happen to fall into that very specific niche use case, these companies might actually be selling exactly what you're looking for. So don't rule them out. Take a look at what they're peddling as well, because they got a couple of cool ones for sure. Yeah, much better quality. Already said it. And then, of course, the uniqueness. And here's just a couple of the logos if you want to know what the Yaesu, ICOM, and Kenwood logos look like, just so you know what to look out for when you're getting into the hobby. So, antennas. There's a lot to talk about and cover with regards to antennas, but we'll make sure you get the basics, expand on the basics a little bit, everything you should and need to know regarding them. First and foremost, antennas are purpose-driven tools, and thusly they come in all different shapes and sizes that fit to said purpose. Antennas are designed and made to resonate, usually at a singular frequency. Unless it's a multi-banded antenna, then it's designed to resonate at multiple singular frequencies, essentially. What does resonance mean? Resonance means it's a purely resistive circuit, and thus there's no reactance. If you don't know what that means, that's okay. Essentially what it means is maximum power transfer with minimal losses. So the energy our radio is putting out is being transferred maximally through the antenna. We're not accruing any heat losses. Now, even though antennas are made to resonate at a singular frequency most of the time, not including multibands, doesn't mean we're stuck at that singular center resonant frequency, though. We can transmit a certain amount away, up or down, either side of that said frequency, but not too far, only to a point. As you get farther away from said frequency, the antenna will resonate less and less and accrue losses. At a certain point, it becomes dangerous to our radio gear to transmit too far away from that center frequency, and doing so could damage or even straight up destroy your radio gear. This concept of transmitting away from the center resonant frequency of an antenna, we call it bandwidth. Bandwidth is essentially how far on either side of that resonant frequency it's safe to transmit before worrying about damaging our radio. We measure it in hertz, kilohertz, megahertz, gigahertz, etc. An antenna with a bandwidth in the order of gigahertz is huge, but like any metric prefix of hertz is technically acceptable. Bandwidth is determined by standing wave ratio, or SWR. Now, SWR, we determine SWR by doing a sweep of frequencies across the entire range to find the antenna's range or bandwidth. And we do this with an SWR meter. Now, SWR is a ratio, meaning a perfect SWR of 1:1. All of the power that our radio is generating goes out to and radiates off of the antenna into free space. As SWR goes up, so example 1.5 to 1, 2 to 1, 3 to 1, etc., more and more power is reflected back from the antenna and possibly could go into our radio, and we also accrue heat losses as well. I did a couple of colors here. So 1.1 would be a perfect SWR. Our antenna is radiating everything our radio is throwing at it. 1.5 to 1 is just fine. There's nothing with that. 2 to 1, we usually consider the safe upper limit of what we can transmit with. And then 3 to 1 is a no-go. Basically, no matter what you're doing, if you got a 3 to 1 ratio, a standing wave ratio between your antenna and your radio, that's the danger zone. We don't transmit anything at 3 to 1 or higher because we can damage or downright break or brick our radio equipment. To kind of illustrate this a bit, on the left you can see this is from a rig expert. We've got a sweep of the 40 meter band, so everything in the blue there is the 40 meter band, 7 to 7.3 megahertz, centered on 7.1 megahertz, and we got 120 kilohertz on either side as well. So as you can see, as we go from left to right, we're at about a 2 SWR. It kind of dips down all the way to 1.04 SWR at 7.071 megahertz, and then it goes back up again. Remember, we got a sweep over a wide range of frequencies, and that's how we're determining the bandwidth and SWR sweep of our radio. And then, for example, on the right, I did include a graph of a multi-band antenna, a trapped inverted V dipole, and we got some readings here on the 40 meter band, 30, 20, and 17. And as you can see, how this antenna is designed is it's got deep nulls, SWR dips at particular frequencies on those main bands, so we can transmit on multiple bands safely. Now, staying on the topic of antennas, we're going to go over antenna polarization. Now, antennas have this thing called polarization, and essentially what polarization is the direction/way the radio waves are wiggling or oscillating when they radiate off the antenna. This is primarily determined how you mount, or in some cases feed, your antenna. And by feed, I mean how the feed line, or coax in some instances, is attached to the antenna. Now there's 3 main polarizations we're going to talk about and cover, and they are horizontal, vertical, and circular. When we talk about horizontal and vertical, especially polarization, we're talking about it within reference to Earth's surface/center of gravity. Circular polarization is not as common as horizontal and vertical. It's usually reserved for things like satellites, because satellites tumble and spin as they fly around the world, and there's also the Doppler effect that we got to worry about as well. So, the relationship between the two: horizontal polarization is essentially just vertical polarization shifted 90 degrees, and vice versa. And what this means is that if you take a horizontally polarized antenna and you turn it 90 degrees, same antenna, but you've now got a vertically polarized one, just because of how you have oriented and mounted that antenna. So if it's kind of the same thing, why does polarization even matter? Well, quite simply, out-of-phase antennas, or antennas that don't match polarization-wise, have degraded and quieted signals between the two. Out-of-phase antennas see degraded and quieted signals from each other, and thus the operators should ensure their antennas are in phase for maximal efficiency between the two. For an example, two antennas 45 degrees out of phase will accrue a 3 dB loss, and two antennas 90 degrees out of phase will accrue almost a 20 dB loss. If you don't know how the decibel chart works or what dBs are, well, here's an example. 3 dB loss is approximately 50% loss in perceived power, and 20 dB loss is about a 99% loss in perceived dB power. So, as an example, with a 100 watt HF rig, if two people's antennas were out of phase by 45 degrees, you would see more like 50 watts. Or if the antennas were 90 degrees out of phase, you would see closer to 1 watt instead of the 100 watt that the radio is actually putting out. You're only seeing 99% or 50% at 45 degrees of that. Now, communication is still possible with out-of-phase antennas, but it's extremely degraded and extremely efficient, and why are you making it tougher on yourself? You're trying to communicate with people, right? So let's try to make it easy. So some standards on polarization. There isn't any rules or laws at all, not even close, regarding polarization and how we utilize it. There's just widely accepted customs and traditions that we've had basically forever. And the main ones are for VHF and UHF FM communications, we use vertical polarization. And then for HF, VHF, and UHF, basically all our SSB and AM communications, we utilize horizontal polarization. Again, there's no rhyme or reason, it's just kind of what we've always done, and it's what we always do. There's no rule saying you have to, it's just how the customs work. Now, some graphics to help better visualize and conceptualize polarization. Jeez. We've got on the bottom graph there vertical and horizontal, and as you can see, as the waves come out of the antenna, you've got vertical waves oscillating back and forth this way, and you've got horizontal waves coming off the antenna going like this. Snake does this, snake does that. They're just 90 degrees to each other, and that's horizontal versus vertical. And that's why when you turn them 90 degrees, they're essentially the same thing, just flipped. And then the GIF one shows not only vertical and horizontal polarization, but also circular polarization as well. Enough about that. Let's talk about the Hamshack. This is where we go to play radio. Your first Hamshack, your specific goals and interests will determine the outcome and look of your Hamshack, but no one person's shack and gear is gonna look the same because it's unique to everybody. Your goals and your interest will determine what your Hamshack and your radio equipment looks like. With that being said, some common first Hamshack examples, people that are brand new and getting into the hobby. Some people just buy a dual band VHF UHF handheld. That's what their first Hamshack, for lack of a better word, looks like. Maybe it's a bit more high power than that. You got a dual band VHF UHF mobile rig in your car, or maybe you even got a portable all band all mode rig that you take out hiking, camping, what have you, into the field. Essentially, everybody's got different goals that they're trying to achieve, and those goals are going to evolve over time, so everybody's Hamshack is definitely going to look different. So, I want you to set a goal and work towards that goal. Now, with that being said, HF is definitely where it's at in ham radio. Long distance, or DX, working the world, is definitely where the fun is. And to give you a sense of what a traditional Hamshack kind of looks like and how it's built, we're going to go over a couple basic building blocks and flow charts of how you would build your first HF Hamshack. And then after we go over that, I'll show you how I got started and my humble beginnings, how my Hamshack evolved over time. Now, for the basics, we're going to start off super simple. We need a 12-volt power supply. 12-volt power supply turns 120 volts AC from our house into 12 volts DC. Essentially everything in ham radio for the most part runs off of 12 volts DC. 12 volt is the nominal rating. In reality, it's about 13.8 volts DC, and everything in ham radio runs off of 13.8 volts DC, plus or minus a couple volts. Most equipment has a range that they can operate with, so about 11.5 to 16 volts, with 13.8 being the sweet spot in the middle. That's what equipment will run with. But a good, proper power supply will put out purely 13.8 volts DC at all times. Now, to connect our radio to, we're going to need some wire between our power supply and our radio, and we usually, a lot of the times, use this stuff called DC zip cord. It's great stuff. You got a red and a black, and they're kind of stuck together, and if you want, you can peel them apart, and you have two separate wires as well. But that's not to say you can use any copper wire lying around the house. Got some 14.2, 14.3 lying around the house or in the shop from a reno. That'll do just fine as well. Now, connecting to that, of course, we've got our main HF rig, our HF radio. Coming out of the back of our HF radio, we've got a feed line of some sort. The most popular is coaxial cable, which is a 50 ohm unbalanced feed line. There are other feed lines, including balanced feed lines, but we won't worry about them. 50 ohm coax is kind of what 99% of everybody uses. And then we use that coax to connect our radio to our antenna. And that's it. Power supply, wire, rig, coax, antenna. You've got the most basic fundamental Hamshack layout that there is. But we can build upon this. We can improve this and make this better. So the basics plus. Again, we got our 12-volt power supply and DC zip cord going into our radio. And then out of our radio, we've got coax once again. But this time, instead of going directly to our antenna, we go into this thing called an antenna tuner. And then from the antenna tuner, more coax into our antenna. So what does an antenna tuner do? Don't be fooled by the name, it's a misnomer. Tuners don't actually tune antennas. They essentially trick our radios into seeing a good SWR match between our radio and our antenna, so that our radio will still run even if there's a bad mismatch. Now, any of the harmful reflected voltages coming from our antenna towards back to our radio, as we said, high SWR, reflected power and voltages, it's essentially going to be stuck between the antenna tuner and the antenna. The antenna tuner prevents that harmful reflected voltage from coming back into our radio. So with this, we can essentially transmit further away from the antenna's resonant frequency. Like I said before, 2 to 1 is mainly the upper limit. We don't want to go too far above that for sure. So we do have some playroom. Antenna tuners essentially allow us to widen that playroom with our antenna and transmit on an even larger bandwidth. To a point, though, antenna tuners aren't purely magical, only slightly magical. You're not going to be able to tune up a rock and use a rock as an antenna. It's gotta be kind of like an antenna for an antenna tuner to tune it up and allow it to work. With that being said, most, but not all 100 watt base station HF rigs, these days at least, most, not all, come with built-in antenna tuners, actually, internal antenna tuners, and they'll do about a 3 to 1 SWR mismatch or lower. But if it's any more than 3 to 1, they usually don't handle it very well. And a lot of external antenna tuners will do up to a 10 to 1 mismatch, which is quite huge, or even higher. So you might not need an antenna tuner if your HF rig does have an internal one, unless your antenna is severely mismatched or you're trying to get really wideband use out of your antenna. Upgrading from a basic plus to more of a modest design, this is what it might look like. Again, we've got the same situation as before with our antenna tuner in place, except now we've added another radio essentially. A modest Hamshack might have the aforementioned HF stuff, but you might also add a 2 meter 70 centimeter, a dual band VHF UHF mobile rig into your house as well. And for that, hook it up to the power supply, and then you're also going to need some coax and a dedicated antenna to match the frequencies that you're operating with. Remember to use the appropriate antennas. HF antennas don't work for VHF UHF, and vice versa. UHF VHF antennas don't work for HF. So with this setup, we've got two antennas. We've got a 100 watt HF rig with an external antenna tuner, and also a 50 watt dual band mobile. Now, continuing on, we might look at a more moderate setup. What do we got here? So before we only had a power supply, but here our power supply is connected into a power gate or a power switcher, and additionally we also have a battery backups plugged into this power gate or power switcher. What do these devices do? Essentially, they automatically and seamlessly switch over all of your radios and equipment to backup battery power in the event that you lose mains power during a power outage. So if you're operating, you're during the middle of a transmission and operating, you wouldn't even notice that you've lost power, except for your lights and what have you. It's going to automatically switch you over to battery backup power. You're not even going to notice a thing. And again, all of our radio equipment can run off of this power gate or power switcher. Now, expanding on this even further, more of an advanced setup. This is a flowchart that I designed for me specifically, and this is kind of a shack design that I'm personally aiming towards at this point in time. Up on the top there at the left, you can see we've got our power supply and our battery hooked up into the power gate, but we've also got a solar panel hooked up there as well. That power gate specifically from West Mountain Radio does have a small 10 amp solar charge controller in it, so it'll do 60, 80, maybe 100 watt panel. But if you wanted to do any more solar than that, you'd need a larger dedicated solar charge controller. But essentially, the idea is we have both mains power supply, battery backup, and solar to recharge everything into this automatic seamless power switcher. After the power switcher, we go into a voltage regulator. Essentially what a voltage regulator does, it assures that everything after the chain, in the chain, sees a very clean and smooth 13.8 volts DC, or whatever you program it to do. Any sudden voltage spikes or drops are going to be smoothed out and your radio equipment won't see them. And in the event of a continuous voltage drop or voltage spike, it will automatically kill the power to prevent damage to any of our radio equipment and accessories, because not only voltage spikes, but voltage dips as well can sometimes hurt radio equipment. It usually shuts off, but more specifically, the radios might still run, but it'll protect your battery. Batteries don't like to be run below certain voltages, so killing the power protects your battery for voltage drops as well. After our voltage regulator, we've got a breakout bar or a breakout panel. Essentially what this thing does is you've only got so many connections on your power supply. This is essentially like a splitter. It's got an input fuse that you can a singular input that you can fuse to whatever you want, and then multiple outputs that you can use to connect your multiple radios and multiple accessories. And as you can see in the picture there, they mainly run off of ATC or ATO fuses, so they're super easy to replace if you blow one. And then of course you're going to want to fuse appropriately depending on what radio or accessory you have plugged into that specific slot, so you can pick and choose your appropriately sized ATC fuse and plug it in that way. Now after that, we've got again our dual band mobile rig and our HF rig. But in this instance here, again, this is what I'm kind of working towards. 100 watts is plenty for me on HF, but I do want more power, especially on 2 meters for working faraway repeaters. So after the dual band VHF UHF rig, I do have a 2 meter amplifier there. And that will allow me to, yes, longer distance simplex, but also those faraway repeaters is kind of nice. After that, we've got a new unit here that both of our rigs are being fed into, and this is a combination SWR and power meter. This MFJ unit specifically shows SWR, forward power, and reflected power, and it can do both HF and VHF UHF at the flick of a switch on the unit. So I can kind of monitor all the power and SWR readings that all my radios and antennas are seeing all at once. Now, breaking out after that, on the HF side, the blue lines here, we've got our external antenna tuner. That does come after the SWR meter. And after our antenna tuner, what we have here is called a coax switch. So coax switches allow multiple coax devices, like an antenna, to be hooked up to a single radio, or vice versa, multiple radios into a single coax device, like an antenna. You can't use multiple devices or radios at once, though. You do have to switch between them one at a time. Only one can be in line at a time, so think switch, not a splitter. It's a coax switch, not a coax splitter, so only one can be used at a time. After that coax switch, I do have my horizontal trap dipole, and at the very least, I personally am looking for a dummy load, if not also a vertical HF antenna as well. Essentially what a dummy load is it's kind of like an anti-antenna. It's made to dissipate your transmissions, whatever you're transmitting into it, as heat, so it doesn't radiate out as good radio waves for others to pick up. And we utilize these for testing purposes mainly. Now on the VHF UHF side, the green arrows, again, we got a coax switch, and we've got that vertical that we saw earlier, and another dummy load. And then also we have a Yagi beam antenna. Kind of focuses all of our energy into a sharp beam, so we can get out farther. And that's one of the antennas that I don't have yet that I'm trying to add to this diagram. Now, with that being said and that being covered, start small, start simple. Those are just examples of how one might build their first HF station over time. The idea was kind of just to give you a basic understanding and the building blocks on how to start and expand your first Hamshack in a block diagram flowchart form. It was just an example. Building your Hamshack into the masterpiece that it eventually will become does take time, effort, and money. You better believe it. Don't worry about building the biggest, baddest, most expensive shack right off the hop. Ease into it. Treat it like a marathon, not a sprint. Now, I want you to start thinking about your interests and objectives and what they are within the hobby. You got to set a goal, and you got to slowly work towards and progress towards that goal or ideal. And slowly but surely, you will start to achieve that, but you got to set yourself a clearly defined and achievable goal first. And of course, remember that some people's first Hamshack is simply a $20 Baofeng from Amazon. It's going to be unique to you. So, as an example, I'll show you how, over time, with time, experience, information, and money put into it, how one's Hamshack might evolve. This was my first Hamshack, and how it kind of evolved over the first couple of years. So before I even signed up for my course, I dabbled in shortwave listening and scanning. My first kind of intro to this was an RTL SDL dongle kit. That specific kit right there off of Amazon, I think it was like $50. You got the dongle itself, you've got some antenna stuff, stand, suction cup, coax, what have you. It was a decent first receiver for VHF UHF, considering the price, and the software was free, so that was pretty good too. But with that being said, it's really not great for HF or shortwave listening. They're not really designed, even with a proper antenna, those units aren't designed to receive those lower frequencies very well. They just don't have the capacity for that. So, again, I evolved and upgraded. I eventually got a better SDR receiver, an SDR Play RSPDX. And the unit itself was very nice, but my antenna was simply, I think there was some old 14.2 house wire lying around in the shop, and I cut a random length. I don't know how long it was. It could have been 50, could have been 150 feet. Connected it up to the SDR receiver and ran it out through the bushes and the trees, and it was quite that simple. Now, this SDR play receiver was better on VHF, UHF for sure, but it was leagues ahead better on HF. These are purpose-built, high-quality receivers that are designed to go all the way down to 1 kilohertz, all the way up to 2 gigahertz with the SDR receiver. And it's got matching professional accompanying software as well. Now, after some time, again, I upgraded, and I added a discone antenna. I absolutely love these antennas. For me, put mine up on a galvanized TV antenna tower, roughly about 50 feet in the air. Remember, with any antenna like this that we're going to be focusing on VHF, UHF, height is might. So get VHF, UHF antenna up as high as you reasonably can. That is going to do you the most good. These discone antennas are perfect for VHF, UHF, listening and scanning. The perfect antenna for that, but they're still awesome in HF too. At the top of the disc part, you've got a cone and then you've got a disc, and on top of that, you've got a loading coil, so that makes that whip electrically longer. I think it's loaded for about 54 megahertz, the 6 meter band, but it really helps and it does great for HF receiving as well. All of this equipment did tie me over in the meantime. Remember, I said I did all of this before I even booked my course. So I had a lot of fun with this equipment, and it tied me over until I finally got my license. And I would highly recommend anybody to take this path / starting point, even if you're unsure or uninterested in getting licensed. You don't need a license to listen, and all of this stuff in this equipment is super fun. I highly recommend it. And also, with this equipment, I did do some satellite stuff, which we'll take a look at here. But first, this is the RSPDX in the bottom left-hand corner there, and this is the software from SDR Play called SDR Uno. And this is kind of what, this isn't a picture I took, but this is a generalized look as to what I was looking and playing with these SDR receivers. These, however, are pictures that I did take. These are actual images that I downloaded from a satellite that flew over top. It was a NOAA weather satellite, and with a couple of programs and some software and that simple receiver and antenna, I downloaded these satellite images that are constantly being transmitted by weather satellites that fly over top of your head. So there's lots of things you can do with even some simple SDR receivers. Now, things did change, and over the next couple of years after I got my license, I did start to get actual proper ham radio equipment. At this point in time, I got my first ham radio, which was a dual band VHF UHF handheld, does 2 meters and 70 centimeters, and it was the Yaesu FT3DR. Those handhelds are 5 watts. To accompany it, I did get an external house antenna. I had to say goodbye to the discone, but I did put up a dedicated 2 meter, 70 centimeter vertical on that galvanized TV tower. And in addition to that, I did put a mag mount on my car. So what this allowed me to do is I would take off the stock antenna, and I would essentially, between home and the car, switch my radio between the house and the car, plug it into the appropriate antenna, and take it with me wherever I went. Now, of course, that isn't an ideal situation, and it's kind of a pain, so I eventually upgraded once again. After a little time, I eventually got a dedicated dual-band VHF-UHF mobile, the Yaesu FTM400. The FTM400 stayed in my car. I fully installed it, did a proper fixed install, and I kept my handheld either on my person or at the house with the house antenna. Now, even though the car mobile rig is 50 watts, so a lot more power than 5 watts, I wasn't too concerned because not only was that antenna at my house about 50 feet up in the air, even when connecting my 5-watt handheld to it, the additional height and the gain of that dedicated antenna was a lot higher, so it really did make up for 5 versus 50 watts. And this kind of setup of one dedicated in my car and a handheld being on my person or at the house did work for quite a bit of time. But as it happens, I wasn't satisfied just quite yet. So I got another dual band VHF UHF mobile. This time I got the Yaesu FTM 300, similar to the FTM 400, a bit newer, 50 watts, 2 meters, and 70 centimeters. So the FTM 400 stayed in the car, the FTM 300 went in the house, and the handheld was then freed up to be on my person to take with me wherever I went. So now I got a radio for my car and my house, and to keep with me as a person. Plus all my SDR equipment as well. Now, even though I had 2 mobiles and a handheld, and some SDR equipment for HF, it didn't satisfy me quite fully. I was tired of just receiving on HF and shortwave listening with my RSPDX, even though it was very good at what it did. I wanted to transmit. It was at this point I got my very first HF rig, which was an ICOM IC735, which is a rig that came out in 1985. It's a bit of an older rig, but it's a workhorse and it did just fine. I actually borrowed this HF rig from a local ham, the only other local ham in my area. Yep, there was just the 2 of us. And I didn't even actually ask to borrow it from him. He had offered and loaned me the rig. Gave it to me on loan to be returned at a later date. So, at this point in time, I had all my bases covered. I had a dual band in the car, a dual band at the house, a handheld to have on my person at all times, and a proper HF rig at the house. 100-watt HF rig. After some time, I eventually saved up some money, and I got my own new HF rig, and I returned the loaner to the ham where it resides today. And the new rig that I got was the FT891, and I got it for a couple of reasons, mainly so it can be an okay house rig, but also I can take it portable as well. But as you can see, we've gone over a lot of equipment, but this progression has been about 3.5, 4 years in the making. As you can see, it takes time. Ham shacks grow and expand over time. It does take time and money, of course. So treat it like a marathon, not a sprint. Your equipment will evolve and expand over time as well. As you can see, mine certainly did, and it continues to this day. Now, that was just an example of how my progression started. What about you? Where do you start? What should you start with buying? What kind of path should you go down? I've got a couple of ideas based on my experience. It all centers around your budget. Your budget is the first question you should ask whenever you're getting new radio equipment, regardless if you're getting your first radio to put in your first Hamshack or your 100th. It doesn't matter. Everything centers around your budget, and everybody's budget will be different. You personally are going to have to decide on this, and remember that if you're not just buying a handheld, you will have incidentals. You have power supplies, wire, coax, antennas, external antenna tuners, etc. If you're not buying a standalone handheld, you've got a lot of different things to include in your budget. Now, with that being said, a couple of ideas. First of all, the infamous Baofeng. That is a perfectly acceptable starting point. If it's all you can afford, the humble Baofeng, just buy the Baofeng. What's so great about the proliferation of these cheap Chinese handhelds is that it severely lowers the barrier to entry and allows basically anyone to get into the hobby without even close to breaking the bank. If that's all you can afford, that's your first shack. There's no problem with that. But if you have a little bit more money to spend, maybe you've got enough money to afford one good Japanese radio. I didn't do it this way. I started with my FT3DR, but looking back, This idea number 2, given the amount of money that I had, is what I should have done, knowing what I know now. If you can only afford one Japanese radio, I would recommend buying a dual band 50-watt Japanese mobile and a Baofeng as well. It's an extra $20, and for an extra $20, you've got a handheld that just works. So now you got both a handheld and a decent 50-watt rig, whether you choose to put that in your car or in your house. Another idea, maybe you got a little bit more money, you could buy 2 dual band 50-watt Japanese mobile rigs, one for your house and one for your car. And again, for an extra $20, you can throw in a Baofeng handheld to get that to get personal communications covered as well. Or alternatively, if you only want one or only need one dual band mobile rig, you could get one Japanese mobile and one Japanese handheld. But I would personally recommend getting one for your car, one for your house, if you have both a car and a house to put one in, and a Baofeng. But one Japanese mobile and one Japanese handheld is a viable alternative. Another idea, if you can afford 3 Japanese radios, we're getting into a bit of a decent amount of money here. Buy dual band 50-watt mobiles for your house and your car, and buy a 50-watt or buy a 5-watt Japanese handheld as well. If you've got the dough to spend, well, just go all in. Get some really nice, high-quality, feature-rich, reliable Japanese equipment. And of course, if you got just cash to burn, you could do any of those previous ideas, or HF and all its accompanied equipment. If none of the VHF, UHF stuff interests you, you could just go straight to HF and skip VHF, UHF. I wouldn't recommend it, but if that is kind of your niche, then it's perfectly viable. Or if you've just got the cash to burn, you could just do all of the stuff. You can get 2 mobiles, one for your house, one for your car, good Japanese handheld, a good solid Japanese 100-watt HF rig. If you're Mr. Moneybags, you go all in. If you got the money, hop into HF, get all the things, all the accompaniments. Consider yourself lucky. You're a rare breed. Not a lot of us have all of that cash to burn at the beginning. I certainly did not, and if you don't as well, don't worry about it. The majority of us don't have a whole lot of money to start with when getting into the hobby. So we've covered a lot of ground. Let's do a little recap here. First of all, start listening now. Whether it's a free WebSDR, a cheap RTL SDR dongle, a more expensive SDR play, a shortwave receiver, a dedicated scanner, start listening now before you even book your course or take your test. You don't need a license to listen, and you'll get a good feel when listening to the airwaves whether you will truly embrace and love the hobby or not. And you can do it for cheap. You can do it for free with a WebSDR. If you want your own stuff for your local area, you can do it with an RTL SDR dongle. You're not spending a lot of money, and it's giving you good insight as to whether you will truly like the hobby and where it will lead you. Take the test. If you are interested and you know that this is up your alley, it's as simple as booking a course and take the test. Your first license is a license to learn. It's not hard, and it will allow you to get on the air and immerse yourself within the hobby right away. Also, please remember, it's a marathon, not a sprint. You don't have to know everything or have and buy everything right from the beginning. You will learn more and you will expand your equipment with time. Set clear and obtainable goals. You don't want to not set any goals and just kind of be wandering aimlessly, but you don't want to set unachievable goals that it's not like you're going to put tens of thousands of dollars into a super station, a super HF station. You got to set reasonable yet clear and obtainable goals for what you want and desire. So whether that's UHF simplex between you and a friend, work in VHF repeaters, or work in the world with HF, set a reasonable goal that you can obtain and work towards it. And continue to set more goals over time as well as you achieve them. Become a sponge. Learn to love to learn. I know it's a funny saying, but learn to do your own research and love learning on your own time. You'll find great benefit in doing your own research and learning on your own time, and not just solely relying on others teaching to you or at you. And last but not least, just buy that radio. Don't suffer from analysis paralysis. There's a myriad of brands and form factors and features. It can make your head spin at times. Don't suffer from analysis paralysis. If a radio you're looking at covers all the objectives that you want to meet initially, go for it and buy it. Whether it's an SDR dongle, the humble Baofeng 50-watt mobile rig, fancy new HF rig, or even a loaner from a local ham like me, once you obtain your license and buy that first radio, just get on the air and start having fun. Once you are on the air, that is truly where your learning journey begins. I know it sounds like you probably covered a lot and did a lot to get to that point, and you certainly did, but what's even more beautiful is that at that point, once you're on the air finally, that's where the journey truly begins. Well, that's it, guys. Thanks for staying with me there. I know it was a long one. Staying till the end of the presentation. It means a lot to me. Like it if you liked it. Dislike the video if you disliked it. If you have any comments, questions, concerns, please leave that in the comments below. And especially if you have any constructive criticisms, let me know below in the comments as well. Constructive criticism and input and feedback lets me know what I can improve on and how I can improve upon my teaching style, my videos, and my presentations themselves. So I hope that with this video you were able to expand your knowledge within ham radio, kind of give you an idea of how to get started and how to build your first ham shack, and really truly begin, finally, not just theoretically but practically, your journey within the ham radio hobby. But that's all for now, guys. I'm Eric, VA3FYB, the ham radio hoser, and until the next one, 73.